Hello. Can. Good morning, all of you. I welcome you all to this talk on the asteroid day lecture, the new exciting era of asteroidal exploration. So today's speaker is Dr. B.R. Guruprasad. He is the director of JNP, and we know a lot about him, but for the people who are listening to his talk for the first time, I would like to make a brief introduction of the speaker. So Dr. B.R. Guruprasad is the director of JNP, and before serving here, he has served in ISRO as a scientist and as a science communicator for almost 3 decades. And his passion for science communication, not only in English, in Kannada, but also in Kannada, has led to almost 13 books on astronomy and space in English and Kannada. And he has also contributed to many encyclopedias. So he has conducted more than 600 ISRO exhibitions in India as well as abroad, and many water rocket making workshops and launch competitions at national and international level. And he has conducted more than 150 quiz programs in many institutions, and as a part of in many parts of India in radio and television. And these are just some of his achievements as a scientist and science communicator. I'm very happy to welcome him, and I request him to take over and start today's talk. I once again welcome you all. Thank you for being here.
Hello, yeah. Good morning to all of you, to Jain Planetarium on the occasion of the observation of the World Asteroid Day. Today is supposed to be 30th June. United Nations a few years back designated this as the World Asteroid Day, because what is the significance of today? About more than 100 years back, exactly in 1908, okay, there was a huge explosion over a region called Tunguska in Siberia, and because of that 1200 square kilometers of forests were destroyed. Fortunately, all of you know that Siberia is very sparsely populated, in fact. So because of that, not many lives were lost, at least not in hundreds or thousands at least. But anyway, this event, which almost 115 years back, 116 years back happened, reminds us of the threat posed by asteroids, okay, which are small bodies in the solar system which go around the sun. Of course, comets also do the same, that is, they also revolve around the sun. And some of the comets, it's very rare, they also have the capability to come and collide with the earth and create havoc, okay. Just to give you one more example, yesterday at around 7:20 p.m., roughly let us take it, yesterday evening, whether we like it or not, an asteroid, okay, an asteroid is, you can think of it as a space rock, okay, which is as large as Eiffel Tower, okay, Eiffel Tower, let us say about 500 feet tall, that is 50 stories high, let us say. So That asteroid passed by Earth. Okay, it passed very near to Earth yesterday night. Believe me, it was about 500 feet wide. That means if you keep it vertically, it is as high as a 15-story building, roughly Eiffel Tower, I said. It passed by Earth at a whopping tens of thousands of kilometers per hour, if I am correct, 34,000 kilometers per hour at a distance of 2,95,000 kilometers. To put it in the proper perspective, Moon, which is the nearest heavenly body to Earth, is at a distance of 3,84,000 kilometers on the average. Moon is at a distance of 3,84,000 kilometers, but this asteroid, which passed by Earth, that is very near to Earth, that is less than 3 lakh kilometers away, was capable of destroying a city. But fortunately, it passed by the Earth and it did not come very near to the Earth. Similarly, last Thursday, 42 hours before, there was yet another asteroid, okay, which was as big as Mount Everest. It also passed by Earth, but fortunately, it did not come very near to Earth. It passed by Earth at a distance of 6.6 million kilometers. So whether you like it or not, these things are happening, okay, in the world. Okay, we on Earth were sitting ducks once upon a time, but not so now. Okay, fortunately there are many methods, there are many avenues for us to protect ourselves. So asteroids can threaten life on Earth. Okay, so they are the heavenly bodies which come very near to Earth sometimes, and it is very essential for us to know what are these asteroids, what kind of things they are, what is their composition, why do they come near the Earth, and why they are like that, and all these questions can be answered if you were to think of asteroids more seriously, in fact. So, considering the threat posed by asteroids and a few examples in the history of the Earth in which asteroid collisions have taken place and caused havoc, So, United Nations has designated 30th of June as the World Asteroid Day to make us remember Tunguska event also in this regard. So, the topic of my talk today is the new exciting era of asteroidal exploration. What is this? The new, the exciting. Why it is? Why today, the present time can be called as the new as well as the exciting era of asteroidal exploration. Is there any reason for that? We'll go through these slides and let us see. Why I call a new exciting era? I don't know, it's not working. Okay, fine. Thank you. Look at that. This is the picture of a spacecraft that is going to explore an asteroid called Psyche, P-S-Y-C-H-E, Psyche. This will be sometime in 2029. Okay, but the spacecraft has already been launched on October 13th of last year itself. But it takes a lot of time for the spacecraft to go and go near this Psyche asteroid and to explore it. You know, somebody, especially the Forbes magazine, it seems it estimated the value of this asteroid to be $10 quintillion. $10 quintillion. Far, 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 far higher in value than the world economy as such, whatever is there too. Why? It contains very precious metals like platinum, gold, iron, nickel and such things. This asteroid is mostly metallic. So there are plans already to mine the asteroids. Many people are already thinking. And yet another spacecraft Okay, this spacecraft is called Psyche. The name of the asteroid is also Psyche, and the spacecraft which is going to explore it is also called as Psyche. Yet another spacecraft, this is also NASA spacecraft like Psyche, this is called as Lucy. Okay, this Lucy spacecraft actually is going to not one asteroid but two groups of asteroids. Okay, one group of asteroids are in the so called asteroid belt. Let me tell you, I'll come to these things a little later. Most of the asteroids revolve around the sun between the orbits of Mars and Jupiter. Okay, most of them, not all of them. Okay, so that is one thing. And asteroids are there in other places also in the solar system. I'll come to that. But when they come very near to us, we call them as near Earth asteroids or near Earth objects. That includes comets also. But there are a group of asteroids called Trojan asteroids. Trojan asteroids, to be more precise, Jupiter Trojan asteroids, because they share the orbit of Jupiter. 60 degrees ahead of Jupiter, 60 degrees behind the Jupiter. That can happen. They can stay there in Jupiter's orbit without any problem. Okay. So, they are very, very interesting because scientists say that they can tell us the story of the planet formation. Okay, they are like the fossils which are there since the past 450 crore years back or 4.5 billion years back. I will tell you about the Lucy mission, very exciting. That's why I said new exciting era. And those were the two exciting missions. The third exciting mission, last September 2023, this capsule came and fell in the earth in the state of Utah in the USA. This capsule contained very, very precious material from an asteroid called Bennu, B-E-N-N-U, Bennu, not the Kannada word Bennu, okay, not that. This is, I will tell you what Bennu means. Okay, this is the capsule that contains the precious samples inside of an asteroid called Bennu. Okay, the spacecraft which collected this is called OSIRIS-REx. Okay, that is the thing. And this is Bennu. Actually, this is the way it looks. This is less than half a kilometer in diameter. Okay, that's the thing. And you know, the work of OSIRIS-REx was so important. Okay, this is one thing. This is about OSIRIS-REx. And there is yet another mission which is being launched, unlike NASA, by the European Space Agency. Okay, this is called Hera mission, H-E-R-A, Hera mission. What does it do? Some 1 year back, okay, there was an American spacecraft called DART, Double Asteroid Redirection Test, it is called. That is, this spacecraft went and hit a dual asteroid pair. Okay, there are two asteroids. Okay, one larger one, the other one smaller one. This larger asteroid is called Didymos. The smaller one which is going around Didymos is called Dimorphos. Okay, this spacecraft actually went, DART spacecraft, Dimorphos. What did it do by hitting? See, whatever the orbital speed of Dimorphos is there around Didymos, that got changed. Okay, why do we do all these circles? Why is it necessary or essential for us to do these things? The reason is, today or tomorrow or day after tomorrow, we may have to resort to this kind of thing to protect ourselves. It is our survival. You cannot, without studying for exam and preparing yourselves and taking a series of exams like terminal exams and preparatory exam, you cannot go and write in exam direct. Like that, if there is a threat, you cannot just like that go and I will attempt it. You can't say, you have to practice a lot. That is what is being done. So, these things are going on, and in around 2027, 2028, okay, this called Near Earth Asteroid Surveyor, a new spacecraft is being launched to keep a constant watch 24 hours a day on the asteroids which can come and threaten the Earth. This is going to be very near to our Aditya L1 spacecraft, okay, in L1 Lagrangian, near L1 Lagrangian point. Now, let us go to the history of asteroids, okay, how they were discovered. You know, solar system consists of the mighty sun, which is in the almost in the center, okay. It is the most massive body, 99.8% of all the mass of the solar system is concentrated in the sun, okay. And around that there are 8 large bodies called planets, large bodies, 8 of them called planets, which revolve around the sun. And around those 8 large bodies, not all of them, at least around the 6 of them, okay, we have satellites. Earth has 1, Mars has 2, Jupiter has 95 plus, like that you can go on, okay. But Mercury and Venus doesn't have satellites. Then apart from the sun, the planets and their satellites, you have minor bodies in the solar system called asteroids, okay. Asteroids, most of them, as I told you, they revolve around the sun in an orbit, okay, they revolve around the sun in asteroid belt that lies between Mars and Jupiter. And of course, comets are there, they come in from all directions, okay, all directions. You can see here it is coming like this, like this, like this, okay. Comets are also very small bodies, but sometimes they appear very large, that's all. But in essence, they are very small bodies. In fact, asteroids are larger than comets in many respects, okay. And of course, we live on the third rock from the sun, the Earth. And of course, these are the planets which are of the solar system, which are arranged like this in the increasing order of distance from the sun: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus and Neptune. There was Pluto once upon a time, it is now classified as a dwarf planet. See, in the 18th century, there was a mathematical curiosity. There was a German mathematician by name Johann Albert Titius, Titius, okay, sorry, Johann Daniel Titius, okay. He was the person who began a mathematical curiosity like this. You write numbers like this: 0, 3, 6, except for 0, after 3, the next number has to be twice the other one, the previous one. 6, after that what should come? 12, after that 96, like that. So, to this you add 4, this is 4, 7, 10, 16, 30, 28, 52, 100, let us say, something like. Now, you would divide it by 10. 4 by 10 is 0.4, am I correct? Okay. 4 by 10 is 0.4, 0.7, 1, 1.6, 2.8, 5.2, like that, 10, let us say, something like that. What is all these things? Why should we write like this? Okay. Actually, you know, the thing is, average distance between the earth and the sun and the earth, average distance, Sarasari Durante and helteve, average distance between the earth and the sun is only 150 million kilometers, roughly. That is 15 crore kilometers. You call it one astronomical unit, one astronomical unit. So, if you take these numbers 0.4, 0.7, 1, 1.6, 2.5 like this, in astronomical unit, this is the order in, this is the distances in astronomical units, at which Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, like that it comes, let us say. So, in the 18th century, they knew, at least by that time, Cassini had found out what is astronomical unit, okay. Astronomical unit, today I tell you very easily that it is 15 crore kilometers. It was not easy to measure that, that itself is a fantastic story. Okay, then what happened? Mercury is at 0.4 astronomical unit, okay. That is true, no doubt about it. Venus 0.7, yes, actual distance even today it is known roughly, it is in the same range. Earth 1 astronomical unit, that is how we define. Then Mars 1.6. Then there was no planet in 2.8. In this distance, no planet was known. No planet was known, and only 5.2 was Jupiter. Then Saturn was 10. Okay, that was the distance. So then if that were to be the case, why there is no planet at this distance after Mars, between Mars and Jupiter? There seemed to be no planet. Then is there any planet which we are missing? Some people started searching for it. This was only a mathematical curiosity, there was no basis for this. Actually, okay, shall we show the slides? Okay, thank you. It's coming here. Okay, this is Johann Daniel Titius, okay, or Titius. Okay, he is the man who started, but this another German, Johann Bode, okay, Johann Elert Bode, he is the one who popularized this whatever I told you, 0.4, 0.7, etc. So many people thought that there might be a planet at this distance between Mars and Jupiter. There is a large gap. This is at 1.6 astronomical unit, this is 5.2 astronomical unit. So is there anything? Many people started searching for that, and this is the way planets are arranged. I thought I would show you this. Then there is in Italy, there is an island belonging to Italy called Sicily, okay. All of you know about it. Those of you who have read Godfather, they know very well, okay, the novel, okay, or the Sicilian, okay. Sicily is known for many other things, but anyway, in an the capital of Sicily is Palermo, and in the Palermo observatory there was an Italian monk and astronomer. He was a monk, religious man, as well as an astronomer, okay. His name was Giuseppe Piazzi. Giuseppe is nothing but English Joseph, okay. Giuseppe Piazzi. He was searching in his by employing his telescope at Palermo observatory, some region of the sky where he saw a moving body, slowly moving body, okay. First he thought it was a comet. Then actually he found out that it was not a comet, it was not moving like a comet, probably it was a planet. It was decided because the way in which it moved, it betrayed that it was not like a comet. Then actually where it was, okay, it was not easy for people to understand. After all, he was not searching for that hypothetical planet in that region. He was doing something else. He was doing something else, okay. But anyway, accidentally, serendipitously, he saw this kind of thing. And anyway, how do we know that where it is circling the sun? Okay, somewhere in the solar system it is circling the sun, but where it is, okay. And today this is the body, whatever he found, it is called as Ceres, not Sirius, Ceres, Ceres. This is named after the patron goddess of Sicily, in fact, agricultural goddess, okay. So today we know that this is a 1,000-kilometer asteroid, in fact, which is spherical, in fact, and it is classified as a minor planet also. But at that time, where was it? People didn't know, but they tried to calculate its orbit, because only for a short while Piazzi observed and he lost it and he fell ill and it went into this one, oblivion. Then this is, I would always say whenever we talk about mathematics, this gentleman's name is Carl Friedrich Gauss, okay. Those of you might have heard the name Gaussian theorem and such things. He is a German mathematician, with whatever available very little available data, he could able to calculate the orbit of that Sirius, okay, the point of light that moved somewhere in the sky, and he proved that it orbits the sun between the orbits of Mars and Jupiter. So here was a case where something which is in this region was found, it was thought of as a planet. But anyway, no, since the discovery of the telescope, after the planets were discovered, planets were dots of moving light for the naked eye. But once Galileo turned his telescope towards them, they expanded into globes, small globes. But this Sirius, actually it was not expanding into a globe at all. That means it had to be very small. Still it looked star-like to the telescope. It was looking like a star. Such bodies came to be discovered again and again in the same region, and since even when looked through the telescope, they didn't appear as orbs or globes, and they look like stars, they were named as asteroids. Asteroid means star-like. So they appear star-like even to large telescopes. That is the kind at that time. So that is the way the name asteroid came. You know, after Ceres was discovered, Pallas, Juno, Vesta, like that, small bodies in that region, not exactly at that place, they discovered, and you know, like that, and by the end of the 19th century, there were more than 300 asteroids had been discovered, in fact, in the region between Mars and Jupiter. Then there was one asteroid called Eros, which was discovered. Of course, it didn't look like that at that time. Of course, this is the picture taken by an American spacecraft called Nehru. Okay, this Eros, okay, was discovered, and when its orbit was calculated, it was not between Mars and Jupiter. It was an asteroid which was coming near the Earth also. So this is a near Earth asteroid. That is why I said all the asteroids are not in the asteroid belt. So now you see a visualization. So this is Jupiter, this is Mars. Between Mars and Jupiter are most of the asteroids. They are known as main belt asteroids, in fact. But asteroids are found elsewhere. See, I told you, if you take the orbit of Jupiter, not ahead of Jupiter there are a group of asteroids, tens of thousands of them. Behind Jupiter in the same orbit, there are asteroids, or they are known as Trojan asteroids, in fact. Because any unusual asteroid, when they were discovered, they were given Greek names, in fact, some peculiar Greek names. Okay, then some names which were there, they were from, you know, like we have Ramayana and Mahabharata, written by Valmiki and Vyasa, respectively. Greeks have two ancient epics. Okay, there was a great writer there by name Homer. He wrote two epics, Mahagranthaಗಳು. They are called Iliad and Odyssey, in fact. So in Homer's Iliad, these characters were there, and there comes an incident in which there will be a Trojan war kind of thing. Since these names were there, Greek names here, and for these kind of asteroids also they gave such names, they are collectively known as Trojan asteroids. Okay, so they are not main belt asteroids, Trojan asteroids. So this is the asteroid belt. So asteroids all of them need not be in asteroid belt, they can be Trojan asteroids in the orbit of a planet. We too have one or two Trojan asteroids. Neptune has Trojan asteroids. So that is the thing. But the most interesting ones for us, which is of concern to us, is these kind of asteroids, which are near Earth asteroids. There are four types of near Earth asteroids. That is, asteroids which come very near to Earth, except for one group, they all cross the orbit of the Earth. So wherever Earth orbits the Sun, if they were to cross, chances of collision will be there. So one group is called as Apollo group, the other one is called Aten group, the third one is called Amor group. Amor group will not intersect the orbit of the Earth, they come very near. And there is another group of asteroids which are confined within the orbit of the Earth itself, they are known as Atiras, in fact. Okay, just names. Okay, these are the things. Now, this is the thing. In 1908, I told you there was a huge explosion in actually a huge explosion in Siberia, and this is due to an asteroid, they say. Some people say it is due to comet coming and hitting the earth, sorry, and others say the thing is it is an asteroid. That is why World Asteroid Day is celebrated today, June 30th. Then anyway, asteroids came to be discovered in thousands, in fact, in the 20th century. Then came a bombshell, a real bombshell, because in 1979, Luis Alvarez and his son, okay, both of them are Nobel laureates, okay. So they actually propounded a theory that 65 million years back or 6.5 crore years back, dinosaurs became extinct. Dinosaurs were the dominant life forms on the surface of the earth at that time. If any extraterrestrial intelligent being, if it were to be there, were to come, it would have concluded this is the earth is the planet of dinosaurs, no human beings, nothing. But suddenly they became extinct around 65 million years back or 6.5 crore years back. They said this was due to an asteroid hit, okay. So these father and son team, they propounded that theory, and even today it is accepted. It seems 65 million years back, whether you like it or not, an asteroid which is as wide as 10 kilometers, perhaps 10 kilometers, it came and collided with the earth at tens of thousands of kilometers per hour speed, and it plowed very deep into the crust of the earth, wherever today in Mexico there is a place called Yucatan Peninsula. Yucatan Peninsula, that is where it came and hit, they say. So like that, it had a fireball, and the result was dinosaurs became extinct. Not only dinosaurs, many other large life forms became extinct due to an asteroid hit. Okay, that in 1979 they propounded that theory, and now it is being increasingly accepted in the scientific circle. Now, in 1973, Americans launched a spacecraft called Pioneer 10 towards Jupiter. Jupiter is beyond the asteroid belt. Mercury, Venus, Earth, Mars, asteroid belt and Jupiter. Scientists had a lot of concern whether this spacecraft would go and cross the asteroid belt or it will be hit by asteroids, but nothing happened to it. It crossed. Now so many spacecraft have passed through it. Now it is estimated that even in the asteroid belt, where millions of asteroids are there, the average distance between one asteroid and the other is 3 million kilometers. Space is so vast, three-dimensional. So we need not have to worry about it. And of course, Galileo Galilei, he has done a lot to the domain of science, and a spacecraft bearing his name, Galileo, it suffered as much as he suffered in the hands of religious people during the Renaissance period, and ultimately this was one of the most beautiful pictures of an asteroid taken by Galileo's spacecraft in 1993. Asteroids normally they look like celestial potatoes. Okay, Alugadde tara kanisate ashte idu. Nodi look like, you know how big it is. After all, it cannot be compared to a planet. This asteroid is called IDA, IDA, and here from here to here it is about 60 kilometers. That's all, 60 kilometers. But the curious thing was, when this photo was taken and processed by NASA, they were amazed to see a satellite for this asteroid. Earth is 12,750 kilometers diameter, and it has got a satellite moon, which is 1/4 the size of it. But here only 60 kilometer wide asteroid is there. For that a 1 kilometer wide satellite. Okay, it was called as dactyl. Okay, that is it. And then, you know, purposely Americans sent a spacecraft towards this Eros asteroid. I told you this was in 1896 or so, this was the first near Earth asteroid to be discovered. To this asteroid, Americans sent a spacecraft called Near Schumacher, they called it. First it went, it inspected the asteroid, then it went around it, and you know, Americans do it everything colorfully. When this spacecraft was put into an orbit around Eros, okay, Eros is named after the Greek erotic god, okay. So when they put it into an orbit around Eros, the day was Valentine's Day. On that day they put it into orbit. So they did it very colorfully, but anyway, even today it is sitting on the asteroid. And next came Japanese. Okay, after America it was Europe, but today Japanese have done a lot in the domain of space. Okay, they launched their spacecraft called Hayabusa. Okay, so Hayabusa towards this asteroid called Itokawa. Okay, Itokawa is the name of a Japanese scientist. It was named after his in his honor. And Hayabusa spacecraft, I still remember, I told this earlier also, I thought the name Hayabusa, Japanese one, I was thinking it's a very rare name because they have kept that name to the spacecraft exploring something which is very important. But nearly 15 years back when I told Hayabusa, my son said, Hayabusa. At that time he was in PUC. I didn't understand why he also knows Hayabusa name. Then I came to know it is Suzuki Hayabusa motorbike is there, in fact. That is the kind of thing. Hayabusa means peregrine falcon. Giduga ant navu heltivalla, haddu. Adar hesaru, Japan. So that was sent to this spacecraft called Itokawa, and it is not only for going and exploring something. Hayabusa spacecraft went, landed on Itokawa's asteroid gently, but it was not very successful. But anyway, all said and done, it could able to bring out the material, very, very little material from Itokawa asteroid and brought back to Earth in 2010. 5 years it took. It is not easy to go to an asteroid like we go to a planet. Venus, you can go to Mars in 10 months, efficient. You can go to Venus, okay, again let us say a few tens of months. But it is not so in the case of asteroids, because one thing is, first of all, it is very difficult to rendezvous, andre meet madodiruttalla. It is not easy to meet with an asteroid. It's a very small body. Next, when you go very near to it, you cannot characterize its gravitational field because it is highly irregularly shaped. A planet means it is spherical. You know how the gravitational field is there, you can do things, but it is not easy. But that is where the challenge comes. So anyway, Hayabusa 1, it brought the material from Itokawa. Then Japanese did not live at that, and they continued, they persevered, and they selected one more asteroid called Ryugu, R-Y-U-G-U. Okay, Ryugu, look at that. Okay, this is the asteroid, the way it looks like a rubble pile, and this is the one. And to this asteroid, Hayabusa 2 went. Okay, it went in 2017 or 18, and it collected, even earlier it went, it collected, look at the way in which how it collected the sample. See, this is the way it collected the sample and it brought it back to Earth, in fact. So this is the thing. Then in 1999, you see, you need not have to send the spacecraft to know the presence of an asteroid. It may not give you more detail, but radars on the Earth can give you the image of an asteroid. How an asteroid looks and how it spins. You can see in this picture, this is a radar picture from the surface of the Earth. Okay, and this asteroid became the target of the NASA spacecraft called OSIRIS-REx. That is the name of the spacecraft. Very, very big name is there. Okay, origins, etc., etc. It is there. The name of the asteroid is Bennu. Okay, I told you, Bennu means not Kannada Bennu. It is a mythical bird in the Egyptian, in ancient Egypt, the legends of that. And look at that. This is the way OSIRIS-REx went and collected the samples in 2020. Look at that. Look at this animation, how it went, and it has collected, it was supposed to collect some 60 grams, but it has collected more. Look at that, the way in which. What do we do by doing all these things? Why? What is the science behind all this? The thing is, first of all, you have to understand, before you want to deflect an asteroid, you have to understand what kind of a thing, what are its physical properties, what are its chemical properties. Then if you want to just push it away, instead of doing it, you may break it up also. If you don't know the composition and its internal strength and such things. So, by collecting the samples, many of these properties can be known. So, this is the way Osiris Rex collected, and look at that. This is the way the sample collection mechanism, it went and just dug into this one. Yeah, look at that, look at that. It went to the asteroid. You know how big this asteroid is? After all, 500 meters, that's all, 1500 feet. Gravitational field is so low. Let us say if you are there, just put this much of effort, you will achieve escape velocity therein, and it is very dangerous. Okay, so this is the way. And now look at that, whatever went in the previous slide, you know, that mechanism, that round thing is there. Can you see here? This is the one which has come back to earth, and they are analyzing it. You see the way in which people are handling it extremely carefully, because contamination from the earthly stuff should not be there. Can you see here? Can you see here? These are the pieces of an asteroid. Okay, the very precious pieces. They are being now examined. They are being now studied by scientists from different parts of the world. And now, anyway, Osiris Rex, it collected the samples of which asteroid? Bennu. Okay, after completing its mission and bringing back the samples and putting it into a capsule and just pushing it towards the earth, now it has gone on a new mission. There is an asteroid called Apophis. Many of you might have read, in 2029 it is going to hit the earth. There was a scare generated some 15 years back. Then they revised, no, it is not 2029, 2036 it comes very near. Now after refining its orbit, now it is known that even in 2036 it will not happen, nothing will happen. But anyway, we have to be ready, we cannot be complacent. So anyway, Osiris Rex spacecraft is firing its engine in this animation, in this artist rendering. You can see it is going towards Apophis asteroid. That is why it is called Osiris Apex. Okay, it is called that mission. So this is the way Osiris, this Apophis is coming towards the earth. They have shown that. Now the other mission is, other important mission, that is why I said this is an exciting new era. This is the Lucy mission. Okay, this was launched by NASA in 2021. What it's going to do? It's going to explore two types of asteroids. One is the main belt asteroid, that is an asteroid, not one, some asteroids in the main belt. Okay, asteroid belt. That asteroid, especially which it wants to explore in the main asteroid belt, it is called as Donald Johanson. Okay, Donald Johanson. Then it again comes back towards the earth, and it goes towards the Jupiter's orbit. It goes there and it goes to Trojans first. Okay, so actually, though both the group of asteroids are called as Trojans, one is called Greeks, one is called Trojans. Exactly, it goes towards the Greek asteroids and explore, again comes back and again goes towards Trojan asteroids. But anyway, why first of all this mission is called as Lucy? They would have called it this one Trojan asteroid mission or something like that. Why Lucy? Because the reason is simple. Scientists think that by studying the Trojan asteroids, we will be unlocking the secrets of the planetary formation, secrets of the origin and evolution of the solar system, and they look like fossils. By studying the fossils, we have come to know about the origin of the human beings, isn't it? Some, let us say in 1978, an American anthropologist by name Donald Johanson, he was excavating in East Africa, somewhere in Ethiopia. Okay, he found actually the parts of the skeleton of a human being. By very, very carefully observing what kind of a human being or humanoid it was, they came to the conclusion that it belongs to a family which was named as Australopithecus afarensis. Okay, Australopithecus afarensis means southern ape kind of thing. Human being, somewhat like ape in the southern region, they told. Australopithecus afarensis. Okay, but Australopithecus afarensis many people can't even pronounce. That's why they named that female skeleton, the female fossil, as Lucy. Why Lucy? Because Americans, I told you, they are very colorful people. When they were excavating, Donald Johanson's team had played a Beatles song called Lucy in the Sky with Diamonds. So they were playing that song again and again, again and again, again and again. They liked that song. Since they had played it at that time, they named this spacecraft, named that skeleton as Lucy. Okay, Lucy, in terms of biological classification, it is the example of Australopithecus afarensis. But name was Lucy, nickname they put it, and by studying the fossils of the solar system, that is, these kind of asteroids, especially Trojan asteroids, we are going to understand the evolution of the solar system itself. So that analogy was drawn. That is why, after all, by studying the Lucy skeleton, we understood this human evolution. By studying these asteroids, you will be understanding the evolution of the solar system. That's why they named this spacecraft mission as Lucy, in fact. So that is the example of that. And the way in which Lucy goes, you can have a look at it. So difficult it is. Though Lucy was launched in 2023, okay, it went to asteroid belt and it has already explored one asteroid called Dinkinesh. Okay, but anyway, it has not gone to Donald Johansson asteroid at all. No, it is going only in 2026 or so. Okay, 2025. And these are some of the Trojan asteroids. Nobody has seen them. This is only animation. Okay, they are very, very important. So this is the spacecraft, Lucy spacecraft, and this is the way it looks. And it already, when it went to asteroid belt once to get enough push to go towards Jupiter, and it has explored an asteroid there called Dinkinesh. When it was first photographed, it looked like that. This is the main asteroid, this is its satellite. Okay, they called it Salem or something like that. Look at that now. After some time, when they took the picture again, this is the Dinkinesh and this is the satellite. This satellite is not one asteroid, two asteroids. Both of them are touching each other. It is called as contact binary. So this is the way it is. So look at that. This is the way Lucy goes. Once it starts from that pink one, the way in which it goes towards its target, you see how it is going, again coming back towards the Earth, again going out, again coming back towards the Earth. Why? To get gravity assist. Instead of spending lot of rocket fuel, you can use the gravity of Earth again and again advantageously to go away towards the point of your choice. That is the way it is. And this is the way Lucy spacecraft is photographing an asteroid. That is what is shown in this picture, in this artist concept. And as I told you, again I am telling, yet another mission which is going towards an asteroid is Hera mission. I told you, Hera is a mission which is designed and going to be launched by European Space Agency. Most of these things, whatever I showed you, they are NASA missions, except for those two Japanese missions, Hayabusa 1 and 2. So where this Hera mission is going? As I told you, Hera mission is going towards the dual asteroid system. That is, I told you, Didymos and Dimorphos. So those are the things. It has already done a lot. Okay, what this DART mission, which went to Didymos and Dimorphos, what it did? It went towards that asteroid, and the smaller asteroid which is going around the bigger one, it went and hit the smaller one, the spacecraft. So the orbit around the bigger asteroid got changed. Now they have estimated how much it has changed. Earlier it was taking 11 hours 55 minutes to go around that larger asteroid. Now it is 11 hours 23 minutes or something. Look at the capability of humans. But anyway, scientists are not satisfied from studying it from the earth. They want to go there again and see what has happened exactly. Because you have to be very, very precise to in order to protect the earth from any rogue asteroid. Now I am going to show you an animation. What was the DART mission? Instead of talking, if I were to show you, you would better appreciate this. That's why I thought I would show this video. Look at this. This was the launch of DART spacecraft, Double Asteroid Redirection Test, it is called. Look at that, the rocket is going up, okay. Then you see the heat shield which is covering the spacecraft to protect it in the atmospheric journey has separated, okay. The rocket has achieved enough velocity. Now DART spacecraft has separated from the earth. You see this? Look at that. It is actually spreading its solar panel wings. You see, you need to have a lot of electrical power to work like a mobile, okay, in space. And you see the way in which solar panels are deployed near the earth itself. All these things are happening, okay. Now it is leaving the earth. DART spacecraft is leaving the earth, and you see first it has circled the earth and now it is going away, okay. Now, okay, the rocket stage finally has fallen off, okay. Now, yeah, you see the camera filters, this one stopper has this one open, and see DART is near the earth, and the way in which it changes from earth orbit to the orbit of that asteroid, you see, yeah, it will fire its ion engine, and this is the way, yeah, you can see Didymos and Dimorphos around it, okay. So look at that, see this spacecraft when it is going away from the earth and it has reached the asteroid. It has just put out a small Italian satellite to observe its suicidal mission, in fact, okay. So this one, yeah, this is an Italian satellite which was placed strategically to observe the hitting of DART spacecraft to Dimorphos. Again I show here Didymos, Dimorphos. Dimorphos is going around Didymos. Look at that. The target is not Didymos, Dimorphos. Look at that, how DART spacecraft is going. Yes, you can see there. Boom, it has hit, okay. Though the spacecraft is very small, the asteroid is very massive because of the velocity, the momentum, entire thing, mass into velocity. These things have actually ultimately resulted in the change in the orbit of that asteroid. Now yet another mission. I told you why I gave the caption for my talk, the new exciting era. Why I gave this is yet another mission, asteroid mission. This is called as Psyche. I told you in the beginning itself, Psyche, Psyche. This was the 16th asteroid to be discovered, okay, and it was discovered as early as 1852. As I told you, this asteroid is as big as 226 kilometers, 226 kilometers, and this spacecraft is going around 2028. It is going near that Psyche asteroid, and it is going to explore. I told you already, Forbes magazine has estimated the value of this asteroid to be $10 quintillion, $10 quintillion. So anyway, they are going to explore it using various instruments, What does it contain? Is it the exposed core of a planet or something else? Look at that. For example, especially for students, I want to say, we are living on the earth's crust, okay? Below the crust is mantle. Below the mantle is the outer core, which is fluid, then inner core. So, but anyway, if we want to study the core of the earth, we cannot drill a hole there. At the most 11 kilometers, we have drilled the hole into the crust, but it lies below 2,900 kilometers. If you want to study what is at the core of the earth, better study these kind of asteroids, which appear to be the core of a planet. It might not have grown into a planet, or it might have been the core of a planet which got destroyed in a collision, and only this much is there. This is what humans want to understand. Not only on economic value, but intellectually speaking, that satisfies you a lot. And this is the way. In 2028 only they are going to go there and explore that. 2029. Though it has been launched in 2023, 6 years it takes to go there, and for 2 years it will explore. And this is the ion engine called Hall effect thruster. That is the one which is being used, rocket engine. And not only through asteroidal missions, okay, spacecraft missions, we are learning more about asteroids and getting the slowly acquiring the capability to deflect them or to destroy them. First of all, before you deflect and destroy, you have to understand how many of them are there, where are they. So this was a satellite called NEO-WISE, which was circling the earth, and I told you already, this slide I showed you in the beginning, it is called NEO Surveyor, Near Earth Object Surveyor. This is a satellite which is going to be launched into L1 Lagrangian point, that is 15 lakh kilometers from the earth towards the sun. Between sun and earth, from the earth it is 15 lakh kilometers. Our Aditya L1 spacecraft, ISRO's Aditya L1 is in the same region, but they are going to launch it in 2027 or so. Today, students should know one thing: by the time you grow up, go to college and get the job, probably asteroid mining may take place. Asteroids, I told you, Psyche's value is estimated to be worth at $10 quintillion. Okay, this is the picture of an asteroid processing station which is extracting the minerals from the asteroid. May not be 10 years, 12 years, 15 years, maybe in this century. Definitely these are the things which are being contemplated very seriously by scientists. Look at that, this is yet another processing station, and you can see an astronaut. See, one thing, let me tell you, people have walked on the moon. It looks like a kangaroo hop, all of you know that. But on an asteroid it is very dangerous. Unless you have secured yourself to something, you may float into space, because gravity is so low there. Just a little bit of this one if you do, you will escape into space. Gravity is very low. But what is the escape velocity of the earth? It is 40,000 kilometers per hour. Look at that. This is the way probably astronauts are struggling on an asteroid in future when they go for mining. Now I told you asteroids, one thing, the main thing is threat. The second thing is economic value. The third thing is, if you want to understand how the solar system got originated, how solar system got evolved into its present status, the way in which it has changed, we have to study asteroids. Because as per the current acceptance, first there was a lot of gas and dust, which later slowly coalesced into what are known as planetesimals, like asteroid kind of thing, somewhat like asteroid. From there they all came together and formed planets. How that did happen? To understand these things, to understand our own origins, not only origin of the earth, origin of life on earth, even to understand that. When asteroids have been found to contain organic molecules, they are supposed to contain water. The Ceres asteroid has a lot of water. Okay, So, asteroids, study of asteroids is important not only from economic point of view, but to quench the intellectual quest of humans. Okay, this is the second thing. And of course, third thing, the threat. That is the most important thing as far as the study of the asteroids is concerned. And 65 million years back, dinosaurs got decimated because of an asteroid hit, they say. I told you, if an extraterrestrial being were to come and see, at that time it would have thought, Earth is the planet of dinosaurs. Where were the human beings? They were not there. Once dinosaurs became extinct, small animals called shrews, mammals, they were like rats. They were our ancestors from where we have evolved. So if when we are there humans, if this happens, I don't know what happens. That's why dinosaurs were sitting ducks, like sitting ducks. They wondered at what was happening. They could not do anything, but we have the means. So to understand the threat, it is very important for us. See, forget about Tunguska in 1907. In 2013, again in Siberia, there was a meteorite hit.
Collapsed walls, blown out windows, streets littered with shattered glass. The Russian city of Chelyabinsk cleans up after Friday's spectacular cosmic event. More than 20,000 workers are helping repair damage caused by the meteor. Seen as a fireball streaking above the Ural Mountains, it created a sonic boom. So powerful, it shattered an estimated 200,000 square meters of glass. The meteor was relatively small, just 17 meters in diameter, but it packed a punch and weighed about 10,000 tons. That's the equivalent of more than 4,000 Land Rover vehicles. It raced through the Earth's atmosphere at a staggering 54,000 kilometers an hour, or 15 kilometers a second. Its speed and friction heated the air to thousands of degrees, causing the light show in the sky. Still, scientists explain it was nearly impossible to see it coming.
The meteorite came more or less from the direction of the sun. It was kind of masked. I mean, optically, it would have been very difficult to detect because it was coming with the sun behind it, so we couldn't see.
Fragments of the meteorite are believed to have fallen into this icy lake.
In a matter of seconds, it grew from a small tennis ball to the size of a huge ball. And then there was an explosion, no sound, just an unbelievably bright flash, like magnum. And I noticed that maybe 7 big sparkles went down this way.
The meteor disintegrated between 30 and 50 kilometers from Earth, reducing the force of its impact at ground level. And that's good, because the blast that it produced in the sky was 20 times stronger than the atomic bomb dropped on Hiroshima. Gerald Tan, Al Jazeera.
Okay, now I think you are more convinced than my words. In fact, what happened in 2013 in Chelyabinsk in Siberia, a small meteorite, 17 meters, what havoc it has caused. And let me tell you, I told you yesterday at around 7:20 p.m., an asteroid which is as big as the Eiffel Tower, it passed by Earth at a distance of only 295,000 kilometers distance, at tens of thousands of kilometers per hour velocity. Okay, whether you like it or not. When was it discovered? June 16, that's all. So, if it is discovered very late, we can't do anything. If it is discovered very early, we can go and somehow do something as we did it in the case of DART mission, in fact. So, that's the way. And of course, DART mission has already demonstrated that we can meet the threat of a rogue asteroid coming and threatening us, but sufficient time has to be available for us. Because when you are 1 million kilometer away, just a push this way a little bit, over a period of 1 year it goes somewhere and Earth will be somewhere here. But if it is very near, I don't know how we are going to manage. It is not easy, that much I say. But anyway, asteroid threat is always there, whether you like it or not, okay. But scientists are watching from space. I told you Neo surveyor they are going to launch, and this is a space watch telescope in Kitt Peak Observatory in Arizona. Okay, so lot of things are being observed, and about more than 30,000 near Earth objects have already been discovered in fact. And the show goes on, but we have to take asteroids more seriously, especially their threat we have to take more seriously. That is the reason why United Nations has designated June 30th as the Asteroid Day. So asteroids are creators as well as destroyers, both of them. They have both the aspects. So with that I end my talk. Thank you very much. And if you have any questions, you can ask me.
Thank you, sir, for that interesting talk. If any one of you have any questions, you can ask once.
Any question is there? Yeah, yes, madam.
Namaste, sir.
Namaste.
What happened to yesterday's asteroid, sir? Where it fell?
No, it has gone away from the Earth. Okay, it didn't come and hit the Earth. It passed by Earth at a distance of 3 lakh kilometers, roughly.
The next journey?
Just like that, it passed away. Again, it will come back after some time, after a few years, because it is going around the sun in an elliptical orbit. Okay?
Anyone?
But the distance was really scary. 2,95,000 kilometers, which is less than that of the distance between Earth and Moon. Yes.
Namaste, sir.
Namaste.
So you said that there were so many satellites arranged for the asteroids. So you said it revolve around the Earth first, and then
Yes.
right? How much time does it take to revolve around the Earth?
See, what she is asking is, okay, let me repeat the question. She is asking, I told and I showed a visual in which first the spacecraft will go around the Earth and then proceed towards the asteroid. How much time it will take to go around the Earth? The orbit in which it is put normally, it may take 1.5 to 2 hours. That's all, that much only it takes. Okay, a few hours it will take and then it proceeds. That's okay.
Thank you, sir.
Yes, that boy.
Namaste.
Namaste.
How does asteroids form?
How does asteroids formed? Okay, how are asteroids formed? Yes, sit, no problem. See, asteroids, sun, moon, earth, everything were formed from a gigantic cloud of gas and dust. Gigantic cloud. Cloud andre il kanso moda alla. Gigantic, we cannot even imagine. Great cloud of gas and dust, dhulu. So from that, all of them slowly came together. First they became somewhat like asteroids. Then asteroids like bodies came together and formed planets. Okay? Good. Very nice.
Thank you, sir.
Any other question?
Anyone else?
Yeah, please, that gentleman there.
In 2034, I think there is a rumor or some preparation going in from NASA side. There is a threat of asteroid hit to the Earth. Did you hear about that also?
No, actually NASA report, please. NASA reports are come. You see, in the past 1 week, last Thursday and yesterday, Saturday, 2 asteroids have passed near the Earth. Okay, they are observing it. Okay, but what are all the NASA missions that are going towards asteroids? I told you about Lucy, I told you about Psyche, I told you about the European Space Agency mission Hera, and I told you OSIRIS-REx, what it has brought. Okay, so these are the ongoing missions which are there. But NASA per se to this year some asteroid will come and hit and we have some exercise, no such thing like that. They are observing, that's all. Just imagine in the past 2 days, one asteroid which is as big as Mount Everest, it passed by Earth at a distance of 6.6 million kilometers. That is 17 times the distance between Earth and it is very far away. But anyway, it passed by the Earth. The second one was only less than 3 lakh kilometers, about 2,95,000 kilometers, and the asteroid was as big as Eiffel Tower. So one was very big and if bigger one were to come and hit the earth, the entire life would have been decimated on earth. This was capable of, the smaller asteroid was, if it were to come and hit really, it would have just destroyed a city like Bangalore or New York, whatnot. That is. Any other question?
Anyone else?
Yeah.
Namaste, sir.
Namaste.
Sir, does ISRO have any missions planned for asteroid?
Please do. Kootkode. Does ISRO have any missions to asteroids? The best people will be ISRO people for that to answer. But anyway, at least not in the public domain I have seen any mission to the asteroid. But see, ISRO has already proved its worth in the case of the moon, in the case of Mars. Now it has gone to a very difficult place called L1 Lagrangian point. Aditya is there. So a lot of experience in handling orbit related calculations, it has experience. So I don't think any difficulty will be there for ISRO if it were to undertake a mission to an asteroid. But I am sure that studies would have been done, whether we can go to an asteroid and such things. But no serious consideration or approval for any mission has come, or it has not come to the public knowledge, at least to my knowledge. That's all. Yeah.
Good morning, sir. First of all, I'd like to thank for hosting this series. It was very interesting. So my question is, we have seen the threat of asteroids hitting the Earth.
Yes.
But there are more chances that it will hit the belt from Leo to Geo, especially the so many satellites which are revolving around. So what are the chances that they hit the satellites and Kessler syndrome coming into effect? How devastating that would be? I think before the asteroid hitting Earth, that could be a possibility, sir.
Yeah, very good question. But when an asteroid comes and hits the Earth, that itself is very rare. Okay? But still, three-dimensional space is so vast. Let us say, when even today, may not be big asteroids which are a few meters wide or less than a meter wide. They are not called as asteroids, they are called as meteorites. They are coming and hitting the Earth every time. Okay? Till now, from 1957 onwards, when the first satellite Sputnik 1 was launched, till now, I have not heard any serious incident in which a satellite being destroyed by some debris from space. At least it has not been reported very, very widely, many incidents. But there are many incidents in which satellites have been hit and destroyed by orbiting debris launched by humans. So that is more. Okay, Leo, Geo and such things are in between Meo. All the things getting threatened by asteroid, it is very, very less. If at all hits are there, it is due to the debris created by humans, and Kessler syndrome may come into effect due to the orbital debris created by humans. More than 3,000 satellites have already been launched by Elon Musk in his Starlink, this one. So many satellites, Chinese will not keep quiet. I mean, what I mean to say is every country wants to utilize that advantages of low Earth orbit constellations, communications constellations, because latency is very less. You need not have to wait. Hello? Means it takes some time for the other, you might have experienced in phone, but in LEO satellites that will not be the case. So everybody wants to use that advantage. So all these things leads to lot of satellites, and chances of collision will increase. Increasement, tomorrow there will be collision, I am not telling like that. Chances, probability of collision will increase with the number of satellites. But anyway, to your question, fantastic question, I would say, chances of a debris from outer space, a meteoroid coming and hitting a satellite, okay, orbiting satellite, whether it is in low Earth orbit, medium Earth orbit or geostationary orbit, and harming the satellite constellation and giving rise to Kessler syndrome is very, very less compared to the man-made debris itself which is there. Okay, thank you. Any other question? Yes.
How does comets form?
Comets, how the comets were formed? Comets were also formed in a similar way. Okay, I told you, gas and dust was there. So the thing is, what does comets were also formed in the same fashion. Okay, but the way in which they were formed, the thing is they were formed in a region where temperature was very low. That is why lot of ices are there. Snow is there. Okay, ice and snow means not only water, methane, carbon dioxide, okay, ammonia. So they are all there. So dust, a little bit of rock and lots of ices. Not only water ice, ammonia ice, methane ice. Okay, all these things constitute comet. Yes.
And why does comet hit the sun while the asteroid hits the earth?
Why? I didn't get you. Why?
Why does the comet hit the sun while the asteroid hits the earth?
Oh, fantastic. Why does the comet hit the sun when asteroids hit the earth? Correct? Okay. Who told you? In fact, comets, they are revolving around the sun in different orbits, in different directions and all those things. They come very near to the sun, and such comets are called as sun grazing comets. Grazing means sumune savarkondu hogodu. Sun grazing comet. Some of them, due to some gravitational interactions with other bodies, they may come and just fall into the sun, not hit the sun. There is no hitting the sun. Just when you near the sun itself, you are going to vaporize. Okay, asteroids are in more predictable orbits, that too mostly in the plane. Okay, you take like the plate in which you eat, that its surface is there in a plane. So asteroids are in that. Okay, not that they will also fall, they will also fall, but the thing is, the chances of them falling into sun like that is relatively remote, because they can come in only one dimension kind of thing. Comets from everywhere they are coming. That is good question. Very nice.
And
So,
also we can see things without light pollution. We can see a meteor hitting, and you can see the seven sisters.
Yeah.
And also we can see the Andromeda galaxy.
Andromeda
without
galaxy.
light pollution.
Yes, without light pollution, hopefully we can see, but the problem is light pollution is there in Bangalore. You cannot see the horizon easily. Lot of skyscrapers are there, apartment buildings are there. So it is difficult. If you go outside Bangalore, once upon a time people used to go to Hoskote and all that. Hoskote is far bigger now with lot of skyscrapers. Go 100 kilometers outside Bangalore, you can see things more easily. Okay.
We have to be in a dark and no light area, which is grass. Then we can only see.
Yeah, what you can see?
The seven sisters and
Seven sisters you can see, in fact, no problem at all. Pleiades, Krutika ಅಂತ ಹೇಳ್ತೀವಲ್ಲ, ಅದು ಸ್ಟಾರ್ ಕ್ಲಸ್ಟರ್ ಅಂದರೆ ನಕ್ಷತ್ರಗಳ ಸಮೂಹ. ಅದು ಕಾಣಿಸುತ್ತೆ, ಏನು ತೊಂದರೆ ಇಲ್ಲ. ಬೆಂಗಳೂರಿಂದ ಅದು ಕಾಣಿಸುತ್ತೆ. ಏನಂದರೆ ವೃಷಭ ರಾಶಿ ಇದೆಯಲ್ಲ, ಟಾರಸ್ ಕಾನ್ಸ್ಟಲೇಷನ್, ಅದರ ಹತ್ರ ಕಾಣಿಸುತ್ತೆ.
Okay, what is the real time when asteroids hit?
What's it? You ask me, don't hesitate.
Like the real time when asteroids hit in the real time.
I'm not getting him. ಅಲ್ಲ ಕೇಳಿ ಏನು ನೀವು ಇದು ಮಾಡಬೇಡಿ.
I'm asking that in real time how this asteroid hits. It is very fast or very slow.
Very fast. Very fast. It is traveling at tens of thousands of kilometers per hour. We can't even imagine. By the time we blink once, it would have gone 10-15 kilometers away. Oh, it is not real life. It is very difficult. When you grow up, you will learn all these things. Good luck. Okay? Good. Let him ask, no problem.
The sun, how did the sun form?
How the sun was formed? I told you, no? The sun, the sun, the planets, asteroids, okay? Then comets, everything was formed from the same material, a gigantic cloud of gas and dust. The central portion, lot of things got accumulated. When whatever lot of things got accumulated, when they start compressing onto themselves, slowly in the center, some ignition took place and sun was born. Okay? Thank you.
And also,
Yeah.
And also planets, how do they get temperature? When they're near they get plus plus, when they're far they get minus minus.
Yes, minus minus. When they are near the sun, it is plus plus and minus minus. But even in Mercury, okay, which is very near to the sun, the side which is facing the sun is plus plus, the other one is minus minus. Okay, good.
And also the distance of the Earth and the Moon, they can fit all planets.
No.
But in sometimes if they fit, they will kill Earth.
No, it is not possible because Moon is only at a distance of 4 lakh kilometers.
It cannot fit.
No, it cannot.
But the distance is very far from the Earth, the Moon.
No, not very far.
Not very far, but it's orbiting. But it's like this much.
Oh, yeah, that much is there, that much will not be capable of accommodating so much of planets. Okay, good, thank you. Anyway, I appreciate his, the curiosity, we should not kill it. Let him ask. So, any other question?
Sir,
yeah.
Sir, you said the series has water in it.
Yeah.
Is it possible to bring it to Earth?
Yes, a very, very valid and important question she is asking. The series, okay, this asteroid, the largest asteroid, which was the first one to be discovered, and PHC, I told you, whether I said it contains water, no doubt about it. Can we bring it to water? See, you have water on Earth, okay, as number of people grows, okay, water becomes scarce, okay, but anyway with great difficulty you can manage on Earth by spending some 50 rupees. From series, if you want to bring water, it costs 5,000 rupees. Will you bring it? So though water is there, it is not easy to bring back to Earth. If you want to utilize there, build colonies, okay, build asteroid mining stations, that kind of thing. Utilize that. On the Moon also water is there, but you can't bring it. Bringing it in space is very costly. Okay, you better utilize it. Okay, thank you. Yeah. Okay.
You can talk. I mean,
yeah,
during
after
coffee,
that you can talk
after
to me.
that.
Yeah.
So, I mean, any other questions you have? Yeah,
you
come
can directly talk to me later.
Yeah.
All
So,
others are there.
Thank you all for coming here.
Yeah. Yeah. Some sky resort kind of thing, No. Yeah. I got that. Okay. So the thing is, such things are coming up, like ecotourism. It is astronomy tourism kind of thing. Yes, you can explore, you can visit. Good suggestion. Thank you.
Thank you all. There is coffee being served outside. Please have it before you
Please.
go. Thank you so much.
Thank you. Coffee kudita ba matadana.
Why is